All right. So as we talk and as we go through, we're talking about Mendel. We've been practicing some of Mendel's rules already. Tomorrow we're going to talk more about probability and Punnett squares. So it's important we have an understanding of these rules. So we're going to just take a step back before we go over our new notes. Let's talk about, or let's review Mendel's 3 rules that we talked about before we finished taking notes on Monday. What was his first rule? Looking at your notes. Okay, what word did he find and discover? Mason? Genes, okay? And he said that everybody has them, right? Yeah. Okay, and we're not talking about?
Genes.
We're not talking about blue jeans. Okay, everybody has genes. Those determine your traits. Okay, what was rule? What was rule number 2? What was rule number 2 on your notes? You've got them in front of you. All right. Evan, what was rule number 2?
Offspring have 2 alloys per trait, 1 weekend.
Okay, say it after me. Alleles. That was weak. Say it after me. Alleles. Okay, everybody. All right, so alleles. We all have 2 alleles per trait, at least. We get 1 from Mom and 1 from Dad. Okay, so that was our next rule. What is our third? Okay, our third rule that Mendel had was what, Claire? Alleles can be dominant or recessive. Good. And what was the rule about dominant versus recessive? Dominant hides the recessive. And we talked about that in the bell ringer. Okay? All right. So those are our 3 rules. Now, just like any rule, you've got a couple exceptions. And we're going to talk about 2 exceptions in this case. Okay, the first exception, number 1 exception you're going to put on your notes, okay, is incomplete dominance. Okay, it's called incomplete dominance. I'll go ahead and underline it so you know that it goes in your notes. Okay, incomplete dominance. And in this case, neither is dominant or recessive. Okay, so neither case would be dominant or recessive. Now, there are only certain traits that follow these exceptions to the rule. Okay, and when we have this, and when we have an exception where neither is dominant or recessive, okay, we get what we call a blending. Okay, and that's when we have a combination of the 2 traits. So the easiest thing to describe and to do as an example is when we talk about color. Okay, now if I tell you that my flower is red and I'm going to cross it with a white flower, okay, if it follows the rules of incomplete dominance, we've got an exception to the rule. Okay, what color will my flower be? Raise your hand. Okay, if it's going to follow incomplete dominance, I've got a red flower and I'm crossing it with a white flower. What's it going to be, Ashton?
Pink.
Pink. Very good. And I want you to write that down in your examples. Once I get it up there, I'll show you my picture. Okay, so a red flower crossed with a white flower equals a pink flower. And that's in the case of incomplete dominance. So there's your example that I want you to write down. It can happen with cats and certain breeds of cats. If you cross a black cat with a white cat, you get a gray cat. Okay? There's only certain traits that exhibit this, though. Okay? All right. Now, the second, and some of your wheels are turning. I see them turning, and you're questioning. Okay?
How do they get flowers with stripes?
All right, we're getting there. Bryce just said, well, how do we get flowers with stripes or animals with stripes? Okay? This is the second exception, to the rule. The second exception to the rule is called codominance. All right, Matthew, hold your question for just a second. Write it down if you think you're going to forget it. Okay? Let's talk about codominance. And I might answer it, I might not. Okay? All right. Codominance, that happens when both genes are expressed. Okay, both genes are expressed, so it means both are dominant. Okay, codominant, both are dominant, both genes are expressed, both genes are seen. So in this case, if we had a codominant situation where I crossed a red flower with a white flower, both genes are seen, so what am I going to see? A striped flower or a spotted flower. Okay, so your example, would be a red flower plus a white flower equals a red and white flower. Okay, so a red flower plus a white flower equals a red and white flower. You don't necessarily need to say striped. Mine happens to be checkered. Okay, so this is where we've got both are being shown. Now your dogs, those of you that have brindle dogs or you've heard of a brindle dog. Okay, brindle dogs happen to show both colors of their parents. Okay, so I have a good friend that has a dog. He's a Great Dane and he's a brindle Great Dane. Okay, his name is Camo because he's got a mixture of brown and black. Okay, and he looks, his fur, it's just that short hair. It looks just like he's wearing camo. Okay, but he's got both of those colors. So he was a case of codominance where we had brindle. Matthew, what was your question? How do you mix flowers? Okay, it's when we're crossing them. Remember cross-pollination, germination with seeds, okay, and pollinating others. Okay, we can take different parts from the flowers, produce seeds, okay? All right, Evan. Shh, guys, please be respectful.
Like a brown dog with like blonde highlights, would that be codomination?
Yep. Okay. All right. While you guys have some questions, I'm going to come around and answer them, but I do want you working. You need a half sheet of paper. Okay, you've got 2 questions to answer on your exit slip, and you've got about 3 minutes before lunch, and you'll have a couple minutes after lunch to work on these.